So today I'm going to start particle physics. Okay, in particle physics, I'm going to complete each and every topic that is mentioned in the syllabus of CSIR exam, GATE exam, JEST, and TFR. So each and every topic I'm going to discuss here. If you look at CSIR exam particularly, then you will get a question in C part. In part C, you will get a one question from particle physics, and that question, it will have 5 marks. So you have 5 marks question in CSIR exam. This particle physics is a part of nuclear physics. Complete section is nuclear and particle physics. So from particle physics, particularly in CSIR exam, you will get one question in part C. Every year you are going to get. Okay. So this is very important. So if you know particle physics, most of its questions are simple. So you can easily do. If you are going to follow my class, I assure you that you are going to solve any question of the particle physics. Second, in the GATE exam particularly, in GATE exam, if you look, roughly one or two questions you are going to get in GATE exam, sometimes 3 also, but roughly you can say 4 to 5 marks. ठीक है, 4 to 5 marks. Every time, ठीक है ना, you are getting 4-5 marks in the GATE paper, or you are going to get 1 question, 2 question, ठीक है, 3 questions, depending upon 1 marks question or 1 or 2 marks question like this. So basically here, this topic is very important for you because nuclear and particle physics is a section from which you are going to get 3 questions in CSIR exam, and you can solve all those questions. Similarly in GATE exam. So if you will take care of this topic, you will be a careful, and whatever you are going to follow whatever I am going to discuss in the class, okay, then chances are that you will get 100% marks in this section. So that's why this is very important. What you have to do here, okay, after the class, first you are going to revise whatever theory I have discussed in the class, as well as if I am discussing numericals, you have to solve those numericals at home yourself. So first there will be class. You are going to revise this class at home. Revise at home. Then you will prepare short notes. Short notes you are going to discuss. After every lecture, 1 or 2 lecture, you are going to prepare your short notes. Short notes is not like this. You are going to make the notes. Complete particle physics, it should be within 10-12 pages. Okay? Short note means complete particle physics you should have in 10 to 12 pages, not more than that. What will be the advantage of this? Actually, in first 2 or 3 revision of these 10-12 pages, you will take some time, roughly 10 minutes, 20-30 minutes you may take. But after 2 or 3 revision, hardly you will give 5-10 minutes, 5 minutes or something like this to revise these 10 or 12 pages. So in first 2-3 revisions of these short notes, you can spend 30 minutes, 20 minutes like this, but after that you need only 5 minutes. You just have to go through these pages, everything will be in your mind, and you will be very clear after 10-12 revisions of these short notes. I assure you, everything will be with you. You can solve most of the questions on the basis of that. You will get like this. So this is another aspect. After completing this topic, you will have a test, class test. Class test. Here, with the help of this class test, you are going to understand how much you know about this topic and how much preparation is further required. If you are getting good marks, it means you are well prepared. Go through this, revise it. But if you are getting less marks, it means you further have to study it. We will also have revision classes for the particle physics and for every topic. This is actually for every topic. So revision classes will be there. Revision classes we are going to take. In revision classes, we discuss only formulas. Theory here in this program, I am going to discuss each and every aspect of theory, every finer aspect, not only from this exam point of view, but also from the interview point of view. So if what I am discussing here, you can clear any interview related to the particle physics. Not more than that is required. So here in the revision class, I am not going to discuss the theory. What I will do, I will revise only formulas, and most of the questions which are asked in previous year questions. I will also try to cover those questions here, and again there will be a revision. So it is bound 2 times you are going to do most of the questions of this particle physics with me here. And if you revise it 3 more times, then automatically you can solve any of the question. So this is the way you are going to study. After class test in last, you are going to have part test. Part test will be for complete nuclear and particle physics, and then there will be full length test. So this is the way we are going to take this course. Okay? Not only particle physics, nuclear physics, this is the procedure for each and every course we are going to discuss. Now, next question is, what is the syllabus I'm going to cover here? So next is syllabus. So what will be the syllabus for this? So here in particle physics, sorry, I will start with classification. I will start, first topic will be classification of particles. Classification of particles. So particles may be classified into 2 categories. On the basis of their internal structure, either you know their quark structure or not. On the basis of this internal structure, we can classify these particles into 2 categories. Elementary particles. And can anyone tell me what is the other name? What is the second name? That is, one is elementary particle, and what will be second? Composite particles. Second will be composite particles. So this is one way of classification where we are going to classify all the particles. Either they are leptons, they are photons, they are mesons, baryons, nucleons, hyperons, quarks. Basically, we are going to classify all these particles in 2 categories: elementary particles and composite particles. This is one way of classification. Second classification will be according to standard model. Then I will classify these particles on the basis of standard model. These elementary particles, particularly, I will classify these elementary particles on the basis of a standard model. Now, after classification, I will discuss each and every category one by one. For example, I will start with photons. Then second category will be leptons. I am going to discuss what are their properties, how many families are there in leptons, what are the numbers associated with them, what type of properties they are going to possess, in which type of interaction they are going to participate. Each and everything I am going to give here. Lepton numbers, or every number I'm going to. So second category is leptons. Each and every number we will provide you. After that, after leptons, we will discuss mesons, and then hyperons. This will be baryons, I can say. I write it in another way. They are baryons, which are of two types. Okay? Baryons will be nucleons plus hyperons. Nucleons plus hyperons. Hyperons. And quarks. Last will be quarks. Actually, I will not stop here. After discussing some aspect, I will further discuss d mesons. One more category is there, d mesons. I'm going to discuss, and heavy baryons. Heavy baryons also. Now, their sequence may be different. Okay? Sometimes to explain d mesons, I need something. Similarly, for heavy baryons, I need some other aspects. So after discussing those aspects, I am going to explain you the meaning of heavy baryons and all these numbers associated with it. Heavy baryons will be there. Now, with all these categories, some numbers are associated. For example, with leptons, you are having lepton numbers. So different type of numbers I am going to mention here one by one. But some of the numbers are there which you have to explain, which you have to understand. You need a more understanding of those numbers, particularly strangeness number. Strangeness number. So I'm going to discuss strangeness number. Isospin. Isospin. What is the meaning of isospin? How this number is defined? And this is denoted by I. And its third component, I3. I3 will be there. After defining these numbers, isospin and strangeness number, I will discuss how to write internal structure of these mesons, baryons, heavy baryons, and d mesons. ठीक है, quark structure. We call it as quark structure. All the properties of quarks I'm going to discuss here now on the basis of these numbers and other aspects. Basically, I will discuss quark structure. There is one more way of classifying the particles that is called as eightfold way. Eightfold way. This is another way of classifying particles, eightfold way. But to explain eightfold way, we need hypercharge. We have to understand what is the meaning of hypercharge. Okay. At the same time, I'm going to explain you this Nishijima formula, Gelman-Nishijima formula. Gelman-Nishijima formula. Nishijima formula. Formula I am going to discuss. Okay. Apart from this, okay, after discussing all these aspects, I will discuss three other important properties. That is number 7. First will be parity. Parity. So parity conservation is an important part of these interactions. So parity will be there. Charge conjugation. I'm going to discuss. Charge conjugation. And time dilation. And time dilation I'm going to discuss. And when you are able to, not time, this will be time reversal. Time conjugation, charge conjugation, and time reversal. Sorry. Time reversal. Okay. You combinedly they represent CPT theorem. Charge, parity, and time. CPT theorem. CPT theorem. I'm going to discuss. Now, when you are well aware about strangeness number, isospin number, parity, charge conjugation, time reversal, when you are all aware about all these things, then we will define, okay, we will define different type of type of interactions, and one by one I'm going to discuss these interactions. Okay, strong interaction, okay, weak interaction, EM interaction, electromagnetic interaction, and gravitational interaction, gravitational interaction. Whatever numbers you are aware, whatever properties you have studied, on the basis of which, if I give you a interaction equation I'm going to provide you, then you can find out which type of interaction is this, either that interaction is possible or not. If that interaction is possible, then what type of interaction it is. So on the basis of this, you can find out. So for this, we need conservation laws. So different conservation laws are there. Conservation laws, ठीक है, all type of conservation laws like conservation of lepton number, baryon number, charge conservation, spin conservation, ठीक है, isospin conservation, strangeness conservation, parity, time reversal, everything, charge conjugation, I3, ठीक है, component, third component of the isospin. And here we will discuss a lot of examples. After those examples, you will be very easily, you can find out, okay, given interaction is this one. So this is your syllabus for this course for particle physics. Here I have considered each and every aspect of your exam and every type of exam, either it is gate examination, CSIR, TFR, and NET, ठीक है, or JEST exam. So this will cater all your requirements for these competitive exams. If you are having any question or something, as far as book, one more thing, if you need book, I don't need here, I don't want to recommend any of the book for you, but I want one thing. Whenever you are going through this, whatever I am discussing in the class, I want that you should go through last chapter. Last chapter of concepts of modern physics. Concepts concepts of uh, concepts of modern physics, modern physics by Arthur Beiser, ठीक है, by Arthur Beiser, Arthur Beiser. So for particle physics, I need only this chapter for you. And apart from this, if I need something that you should go through, either I will provide you in the form of PDF, or I will give you the reference and you can go through that. But what I think, you should go through this chapter. This is a very good chapter, very well written chapter. It will be very helpful to you. A overall view this chapter provides you about the particle physics that is required for you. Okay. So this is the syllabus of this particle physics course. Okay. This is the book, and I told you how to study this. ठीक है, आपको short note, you have to prepare short notes, you have to go through those short notes 20-30 times before your exam. It takes hardly 5 minutes to go through the notes of particle physics. So for this purpose, so that you will be so much prepared, you have to prepare short notes. Okay, beta. So I have discussed these aspects with you. If you are having any question regarding particle physics, you can tell me. I will try to answer your question. Anyone having any doubt? Hello. Is there any doubt, particularly for new students? Many of the students, I'm taking their classes from a long time. First, I was discussing classical mechanics, then nuclear physics and particle physics with them. So please, new students particularly, if you are having any doubts, you can ask me. Otherwise, I will start discussing particle physics. And I will discuss each and every basic aspects. मुझे ऐसा कुछ नहीं है कि आपको कुछ आता है या नहीं. I will discuss every aspect of this course. There is no prerequisite for this course. From very basics, I will explain you one by one. I will discuss. Okay. If you don't have any question, then I'm going to start with particle classification, classification of the particles. Classification of the particles. Classification of particles. So basically, particles can be classified into two categories. That is on the basis of their internal structure. Internal structure or the quark structure is known for some particle. For other particles, this quark structure is not known. You don't know their internal structure. So that type of particles whose internal structure is not known to us, they are called as elementary particles. They are called as elementary particles. Elementary particles. Some people also call them point particles. Some people call them point particles. If someday their internal structure will be known to us, okay, then automatically they will also move out this elementary particle category. Earlier, protons and neutrons, they were also a part of this elementary particle category. But now, because their internal structure is known to us, so they are now under the category of composite particles. So elementary particles are those particles whose internal structure is not known to us. This category consists of two type of particles. One is fermions. One type of particles are fermions. Now, what is the meaning of fermions? Meaning of fermions is simple. Those particles, ठीक है, whose spin is half integer, ठीक है, whose spin is half integer, like 1/2, 3/2, ठीक है, 5/2. So those particles which have half integral spin, they are called as fermions. So their spin is 1/2, 3/2, 5/2, like this. So they are called as fermions. And other type of elementary particles, they are bosons. Bosons. Bosons are those particles which are having integer spin. They are going to have integer spin, like it may be 0, it may be 1, 2, like this. So elementary particles, they themselves are of two types, fermions and bosons. Okay, bosons and fermions. In fermions, two categories are there. One category is leptons. Leptons. Okay, one category is leptons. And second category is quark particle. Quarks. Okay, so in fermions, two type of particles are there. One is leptons, another are quarks. So they are fermions. Their spin is half integer. For example, for leptons, three type of leptons are there. Electron family, okay, muon family, tau family. All these three families, they are having half spin. They are having half spin. Similarly, six quarks are there. Their spin is also half. So because their spin is half, so they are fermions. So in elementary particles, there is a category that is called as fermions. In this category, all these particles, leptons and quarks, they are having half of this spin. Half of this spin. Okay? They are also called as interacting bosons. Interacting bosons. They are called as interacting bosons because when we will discuss these interactions, strong interaction, weak interaction, electromagnetic interaction, then we will find out during these interaction in between particles, there will be an exchange of bosons. So basically interaction takes place. These strong, weak, electromagnetic, these interactions takes place due to the exchange of these bosons. So that's why they are also known as interacting bosons. They are called as interacting bosons. ठीक है बेटा? Or exchange bosons. You can also call them exchange bosons. Exchange bosons. I'll give you the name of them after 5 minutes. Exchange bosons. So these are elementary particles. So in elementary particles, fermions, particularly leptons and quarks are there, and exchange bosons are there. Now, second category is composite particles. Next is composite particles. So composite particles are those particles whose quark structure is known to us. So composite particles are those particles whose quark structure or internal structure is known to us. ठीक है? Together, ठीक है ना? In this category, whatever particles are coming together, they are called as hadrons. Hadrons. Together, they are under the category that is called as hadrons. Why you are calling them hadrons? I will tell you later on. Now, in hadrons, two categories are there. One is mesons. Mesons. If you look at mesons, ठीक है, they are made up of one quark and one antiquark. All the mesons, they are made up of one quark and one antiquark. So their quark structure is known to you. तो जो इनका quark structure है, that is known to you. That's why they are a part of composite particles. Second is baryons. 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 In baryons, there are again two categories. ठीक है, first is nucleons. Nucleons. And second category I am writing hyperons. Hyperons. ठीक है, if you look at the internal structure of baryon, I am writing here. Baryons, they are made up of three quarks. They are made of three quarks. So their internal structure you will be able to write after this course. Very easily you can write the internal structure of mesons as well as all the baryons, even heavy baryons and d mesons also. So their internal quark structure is known to us, so that's why they are called as composite particles. ठीक है? Apart from these particles, there is also their antiparticles also. Here I have mentioned only particles, their antiparticles will be there. For example, antibaryons will be there, antimesons will be there, antileptons will be there, antiquarks will be there. Okay? So their antiparticles are there. So this is a broad classification where we are telling, okay, we are classifying all these particles into two categories. Why you are categorizing them? Because there, on one side, you are having particles whose internal structure is known to you. They are called as composite particles. Their quark structure, they are made up of quarks. Mesons, they are made up of one quark, one antiquark. Baryons, they are made up of three quarks. Antibaryons, they are made up of three antiquarks. So you know all these internal structures. They are called as composite particles. On the other side, you are having elementary particles, where two type of particles are there: leptons and quarks, which are fermions. Which are fermions. And on the other side, you are having exchange bosons, by the exchange of which these particles, they are undergoing different type of interactions: strong interaction, weak interaction, gravitational interaction. and this electromagnetic interaction. I want to mention one thing here, that size of these particles is very, very small because their size and mass is very, very tiny. So that's why gravitational interaction we are not going to consider here. So why you are not considering gravitational interaction? Because that interaction is very, very weak here. Okay? Because mass of these particles involved, that is very, very small. Okay? Gravitational interaction, that is very important, where large masses are interacting. For example, astronomical bodies are there, Earth, Sun, like stars, like this. But here particles are very tiny, masses are very small masses are involved. So that interaction is present. I'm not saying if mass will be there, automatically gravitational interaction will be there. But as compared to three other interaction, that is negligible. That interaction you can neglect. So that's why we are going to focus mainly on weak interaction, electromagnetic interaction, and strong interaction. That will be. So this is one way of classification. I will discuss each and every of this category in detail. Every aspect, every property, every number, everything I'm going to discuss in detail one by one. Now, if you look at elementary particles, then according to
सर वीडियो
standard
में
model.
लैगिंग है
Yes, beta?
सर वीडियो थोड़ा लैग हो रहा है
वो कभी कभी हो जाता है नेट की वजह से, अभी सही हो जाएगा. सो तो कई बार मैं तेजी से बोलने लगता हूं तो वो लैगिंग बढ़ जाता है. So basically all these elementary particles, according to standard model, that is the most acceptable model right now. These elementary particles, they can be classified into three categories. So there is next classification, that is for elementary particles. So next is standard model. Standard model. Please write. According to standard model, please write. According to standard model, this universe, according to the standard model, this universe is made of, this universe is made of, is made of fermions, is made of elementary fermions, you can write, is made of elementary fermions, elementary fermions, fermions interacting through exchange bosons, interacting through exchange bosons, through exchange bosons, exchange bosons, full stop. So all these fermions and bosons, they can be classified into following four categories. They can be classified into following four categories. Following four categories. ठीक है? Standard model. Number one, first generation fermions. First generation fermions. First generation fermions. Generation fermions. ठीक है? In first generation fermions, basically electron family is there. Here, this first generation fermions, it consists of electron family. Electron family. In electron family, you are having electron. This is a electron. Electron E minus, and electron neutrino, and electron neutrino. Electron neutrino, that is nu E. Okay. So basically, this first generation fermions, they are made up of electron family, and second quarks, two quarks will be there. Two quarks will be there. That will be up quark, up, and B I can write quark. This is denoted by U, and down quark, down quark. This is D. Below this table, I will make a table here. This type of chart there. उसके नीचे please write A first point करके लिखो. First generation fermions are lightest and most stable. First generation fermions are lightest and most stable. And most stable. Full stop. Most of the atoms are made up of first generation fermions. Most of the atoms are made of first generation fermions. This was point 1. Okay. So this first generation, what is the meaning of first? If someone asks you what is the meaning of first generation fermions, basically out of this classification, first generation fermions are the most stable fermions, and they are lightest of all the three categories of fermions will be there. First generation, second generation, third generation. In this three generation, this first generation fermions, they are the lightest and the most stable. And you will observe that most of the atoms here in this universe, they are involving these electron family and these quarks, up and down quarks. Up and down quarks. So here they are going to consist of these four particles. Now, second category is second generation fermions. I'm writing here second generation fermions. Second generation fermions. I will dictate each and every point that you have to remember. Whatever you have to remember, it will be in your note. Now you have to revise. Only one thing you have to do, that is revision, and revision. Without revision, you are going to forget. And it is applicable for every subject, every topic. Second generation fermions. In second generation fermions, it consists of muon family. It consists of muon family. Here, you can write muon family. In this family, this muon will be there, mu minus, mu minus. And next will be mu neutrino. Mu neutrino or mu neutrino. This is mu neutrino. Okay? And second, two quarks, charm and strange. Charm and strange. Quarks, charm quark. It is denoted by C, and strange quark. Strange quark. That is S. Charm quark and strange quark. Please write number 2 point. Below this table, number 2 point. Number 1 you have written, number 2. Okay. Second generation fermions are relatively heavy.
Sir, please wait.
Yes, please.
Done, sir.
Okay, please write number 2 point. Second generation fermions are relatively heavy and less stable. And relatively less stable. Second generation fermions are relatively heavy and relatively less stable. Full stop. They are involved in the structure of they are involved in the structure of some specific type of atoms. 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 Then third generation fermions. Third generation fermions. Third generation fermions. Fermions. So third generation fermions, they consist of tau family. Tau family. Tau family. In this tau family, you are having ton. Spelling you can check. Tau. It is tau minus. It is symbol is tau minus. And tau neutrino. Tau neutrino. Tau neutrino. So nu tau. It will be like this. And second, it consists of two more quarks. That is top quark. Top quark. T. And bottom quark. Bottom quark B. And bottom quark B. And bottom quark B. Bottom quark B. Bottom quark B. Please write third point below the table. Please write third point. This third generation fermions are heavy as compared to first and second generation. These third generation fermions are heavy as compared to first and second generation fermions. And they are less stable. And they are less stable. And they are less stable. They are less stable. Full stop. In general, they are not involved. In general, they are not involved. In general, they are not involved. They are not involved in atomic structure or the formation of atoms. In general, they are not involved in the formation of atoms. They are utilized for other structure formations. So these are first three. Next column will be third column. Next column will be, you can write, you can make that column, exchange bosons. Exchange bosons. Exchange bosons. In exchange bosons, one is photon. Photon. This photon is responsible for the electromagnetic interaction. During electromagnetic interaction, these photons are exchanged between charged particles. So during the electromagnetic interaction between two charged particles, these photons, they are acting as exchange particles. So they are exchange particles for electromagnetic interaction, EM interactions. 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 Second is gluons. Gluons. Gluons are responsible for strong interactions. Strong interactions. They are the exchange particle for strong interactions. During strong interaction, these are the exchange particles. In between, particles which are involved in strong interaction, they are going to exchange gluons with each other. They are going to exchange gluons with each other. Next is Z naught and W plus minus. They are called as, I can write here A, this is B, this is C. They are called as heavy bosons. They are called as heavy bosons. Heavy bosons. Okay, they are the exchange particles for weak interactions. Weak interactions. So they are responsible. Their exchange of these particles that is responsible for the weak interaction. A lot of names are coming into the picture, but you will become habitual. Slowly and slowly, new names, new things, they are going to come. I cannot explain each and every aspect in one class, but one by one, I will explain you each and everything. Okay? So you are having heavy bosons. What is the meaning of this? How this Z naught, W plus minus, they are exchanged. See, I will explain you everything. So, and last, gravitons.
Gravitatically.
Gravitational interaction. Gravitons. For correct, Buddha. Gravitational interaction. So according to present standard model, these four type of categories are there. So this categorization is corresponding to standard model. Standard model. Now, one by one, I'm going to discuss every category. So I will start discussing every category of particles. So first category is photon. First category. So first I'm going to start with photons. Photons. This is first category. Okay. First thing is they are bosons. Okay. You can write photons are bosons. They are bosons. Why they are bosons? J pi. J means there is spin. Okay, na? And pi means parity, intrinsic parity I am talking about. J pi, J is here representing the spin, intrinsic spin and intrinsic parity. Kitna hota hai? What is the sorry, intrinsic spin and intrinsic parity of these photons? That is 1 minus. Because spin is 1, integer spin it is having. That's why this is boson. That's why this is boson. B, they are massless particles. They are massless particles. massless particles. Massless particles. ठीक है, rest mass is zero. Rest mass of the photon is zero, but they carry momentum. But they carry momentum and energy. But they carry momentum and energy. Energy. ठीक है? What will be the energy of these photons? That will be h nu. H nu. ठीक? Nu is the frequency of the photon. H is the Planck's constant. And what will be their momentum? So energy E, total energy E will be P square. C, what is the formula? P square C square plus m naught square C to the power 4. M naught you are saying 0. So here E will be equal to PC. PC. You can say that P equal to E by C, or you can say H nu by C. This will be the momentum that is carried by a photon. That is carried by a photon. They are very stable particles. Their lifetime, they are stable particles. See, lifetime is very large. They are stable particles. Particles. They are stable particles. D, they are the exchange particle for electromagnetic interaction. Okay? They are the exchange particles. They are exchange particles. Particles of electromagnetic EM interaction. EM interaction, you can write. D, please write, if in a given interaction photon is involved, if in a given interaction photon is involved, suppose some reaction interaction is given to you and gamma or a photon, gamma here, photon is represented by gamma, not every time gamma photon, but photon is represented by gamma here in the particle physics. If gamma is involved, that photon is involved, it means that interaction, if possible, it means that interaction, if possible, will be electromagnetic naturally. So if you are observing some interaction and photon is involved in that interaction, you are looking a photon in that, it means that maybe, if either that is not possible, one thing is this, and if possible, it will only be electromagnetic. It will only be electromagnetic. Okay? If in an interaction photon is involved, then that interaction, if possible, will be electromagnetic interaction. So this will be very helpful in the last section when we are going to decide that the given interaction is which type of interaction. So if in an interaction you are observing a photon is appearing, then you will say, okay, first you will check either this is possible or not. And if it is possible, then you will say that this is electromagnetic interaction. That this is electromagnetic interaction. ठीक है? That is photon. ठीक है? So this will be. तो photon involved है तो ये this will be. So these are the properties that we will require here about photons. तो photon का minimum, at least I need this one. You have to remember, I expect you to remember this one and this one, that they are involved in electromagnetic interaction. If in an interaction you are observing photon, you will say, if possible, then this given interaction will be electromagnetic interaction. So this is first type of particles. Second type of category are leptons. Second type of category are leptons. Second is leptons. ठीक है. What are leptons? First thing, देखिए, first is you can write spin and parity of leptons. Spin and parity of leptons is 1 by 2 plus 1 by 2 plus. Spin कितना है? Spin is 1 by 2 and parity is positive parity. What is parity? I will discuss. So basically spin and parity of leptons is 1 by 2 plus. So they are fermions. So they are fermions. So they are fermions. The first thing is they are fermions. They are fermions. Second, they participate. They participate. Yeah, or you can write they interact through. They can interact through. They can interact through through weak interaction. They can interact through weak interaction or electromagnetic interaction. Electromagnetic interaction. Interaction if interacting particles are charged particles. If interacting particles are charged particles. Are charged particles. ठीक है? If interacting particles are charged particles. See here next, they don't participate. They don't participate in strong interaction. Never in strong interaction. Interaction. They don't participate in a strong interaction. तो वो strong interaction में participate ही नहीं करते. Never. Next, if neutrinos, for example, electron neutrino, mu neutrino, or tau neutrino are appearing in a given interaction. In a given interaction, then that interaction if possible, that interaction should be possible first. If possible, then that interaction will be weak interaction. Will be a weak interaction. Will be a weak interaction. क्यों होगा? I will explain on the basis of parity. Reason is parity. For neutrino, if you look at the mirror image of the neutrino, I'm going to tell you, but I will discuss in detail. Actually, if you look at the mirror image of the neutrino, that doesn't exist. Mirror image of the neutrino doesn't exist in the nature. जो mirror image होता है neutrino का, that doesn't exist in the nature. That's why parity is not conserved. And when parity is not conserved, only one type of interaction will be possible. That will be weak interaction. So mirror image of the neutrino will not be possible. Is not possible, is not existing in this, in our nature. So that's why parity is not conserved. Parity for that interaction is not conserved, because mirror image of that interaction will not be there in the nature. So if that interaction will be possible, that will be possible through an interaction in which parity will not be conserved. So that type of interaction will be possible only through the interaction in which conservation of parity is not there. And that type of only interaction is weak interaction. Weak interaction. So that's why you say that that may be a weak interaction. Okay, that may be a weak. So when I will discuss parity with you, I will explain you this one. And when I will discuss questions again and again, you will find out this thing. So these are not, ऐसा नहीं है कि you have to understand, means these are very difficult things. They will become very trivial if you start thinking in this way, logical way. So here most important thing which you should remember here for me, that they don't participate. They don't participate in strong interaction. वो strong interaction में participate नहीं करते. They don't participate here. ठीक है? It's like this. Don't participate. So you have to remember this. Leptons is made up of three categories. If you look at leptons, they are made up of three categories. Here, I'm writing leptons from here. Leptons. Three categories are there. Number one, electron family. Electron family. Electron family, it will have two particles. First is electron. Second is electron neutrino. Okay? Electron neutrino. Second is, I have to make a table here. I will give you full information here about these leptons. You don't need anything more than that for leptons. Everything will be here. Number two, muon family. Muon family. Muon family, that is mu minus and B mu neutrino. That is this. Neutrinos, they are neutral particle. If you look here in the symbol, they are neutral particles. Plus and minus sign is not here. These leptons particles, electron, muon, ton, they are negatively charged. Third category is tau family. Tau family. Here, A, tau, and B, tau neutrino. Tau neutrino. Now, first thing is, what is their spin and parity? So first is, I am writing spin and parity. Spin here and parity. Here, this will be pi. In general, we write it as J pi. J pi I am writing here. Now, here this will be half plus. This will be half plus, half plus, half plus, half plus, and here it will be half plus. It is like this. Their spin and parity is half plus. Spin and parity is half plus beta. Next, another thing that is defined, lot of particles are there. You have to define that, okay, this is the family. This is lepton family, broader family. You have to give a name to that family. You have to give a name to that bigger family. So that name is leptons. So to define the bigger family lepton, they have introduced a number L. And to every lepton particle, they have given lepton number +1. They are saying that if you are a member of this family, your lepton number is +1. So that is +1 beta. For every lepton family member, here they are representing one single large family. But within this family itself, there is a categorization. Within this family, there are three subgroups. Within this family, there are three subgroups. So we have to classify this family within the three subgroups. So to divide this to represent these subgroups, they introduce three new number. One number is electron lepton number. So this Le number, it is representing the electron family, first family. So this Le is +1 for electron family. For other two subfamilies, that is 0. That number is 0 for other two families. Then you are going to introduce another number for this muon family, subfamily. So that is 0. This is not a muon. This is not a member of muon family. Here, two members of muon family are there, and for them it is 0. For them it is +1. For other, which are not a member of muon family, this number will be 0. So this number was introduced to represent this muon family. Muon family. Now you have to represent this tau family. So for this, they have introduced alto. Alto. And this will be 0 here, it will be 0 here, this will be 0 here, this will be 0 here, and this will be +1, and this will be +1. They are like this. So these are different lepton numbers. One lepton for overall family, one lepton number for electron family, subfamily. L mu is for a subfamily. L tau is to represent a tau family, subfamily. Now, apart from these, there are other numbers also. One is called as strangeness number. What is strangeness? I will explain you. But right now, you cannot make this table again and again. I don't want you to prepare so many tables. I just want one table. So please write here. What will be strangeness number? I will explain you later. Strangeness number is introduced for particles which are exhibiting some specific properties. Those specific properties are not exhibited by any of these particles. They are not representing any of the specific spatial property for which this number was introduced. So strangeness number is 0. Strangeness number is 0. There was another number, I and I3, spin numbers. This is called as iso spin number, and this is called as I3 number. These numbers were introduced for a uh, for particles which are behaving differently in electromagnetic interaction and strong interaction. These numbers, they were introduced for the particles which are behaving very differently in strong interaction and electromagnetic interaction. But these leptons, they don't participate in strong interaction. So this number is not for these leptons. This number is for those particles which are participating in strong and electromagnetic interaction. So this number is actually not for leptons. So remember this number will be 0. One more number you are going to have, that is called as baryon number. For example, here this is a lepton family, so you have defined lepton numbers. Similarly, for the members of baryon family, you have to decide some number. You are going to give a number that is called as baryon number. So they are not baryons, they are leptons. So because they are not baryons, so baryon number for all of them, that will be 0. That will be 0. ठीक है, this will be zero beta. So okay, this was the introductory lecture. ठीक है, today I am going to stop here. In the next class I will continue from here. These are 6 leptons. Other than these 6 leptons, you are having their antiparticles. 6 anti-leptons are also there. For electron, this is positron, nu e. For nu e bar, their antiparticles are there. So I will start with their antiparticles in the next class. ठीक है बेटा, चलिए, thank you very much. I
Thank you,
think
sir.
I will take 6-7 lectures to complete this particle physics. 6 or 7 lectures I need at least. One lecture, maybe more. Okay, beta. Thank you very much.